present you my paper titled Embodied Cognitive Robotics, the Question of Meaning and the Necessity of Non-Trivial Autonomy. So the presentation structure is going to be like this. I'm going to give you a short account of the background of embodied cognitive robotics. I'm going to present to you the field's claims about the nature of meaning. I'm going to present to you which trends are realizing those claims. I'm going to show you the problem with those claims and trends, and I'm going to try to identify and kind of offer a potential solution to the problem. And this solution will be in a form of non-trivial autonomy. And then I'm going to summarize my presentation to kind of wrap it up and offer a short conclusion. So a bit about the background. Embodied cognitive robotics have been like a very huge field since the early 90s, and they've been making progress in many things that were kind of underdeveloped before, especially the problem of symbol grounding, the frame problem, and low-level cognition, which were the problems that were left by computationalism and so-called good old-fashioned artificial intelligence. The main idea that this field latched on is that thought is expressed not as a simple manipulation, but as an inner simulation drawing on lower-level capacities of the sensory motor cognition. So in this paradigm, cognition is seen as embodied, situated, grounded, subsymbolic, dynamic, and distributed in practical activity. There's a considerable number of evidence that speaks to such a position, and this evidence comes from neurocomputational accounts, neuroimaging findings, and cognitive neuropharmacological research. And because the last one is probably the one that you're unfamiliar about, there is an interesting research that, for example, if you constrain someone's body in a way, so for example, if you put Botox in someone's lips so that they are unable to move them, they'll be lacking in emotional responses, in emotional judgments, and so on. So going forward to the claims of the field of embodied cognitive robotics, they especially pride themselves on having made a breakthrough or even solving the problem of meaning, the symbol grounding problem, and that they have kind of figured out the nature of meaning, which is kind of a grand claim to make. And the current debate in cognitive robotics, about cognitive robotics, is that meaning arises through an agent's use of language as a cognitive tool in its active interaction with the environment via sensory motor behavior. So I'm going to present to you 3 examples that kind of realized these claims. And these examples are all kind of picking different pieces of evidence that link language and action to meaning comprehension. So my first example is from the paper of Cangelosi et al., which employs 2 robots and is based on the teacher-learner relationship. So one robot is the teacher and one is the learner. And this is similar to how a child mimics people around it. This model produces so-called grounding transfer, which means that it acquires higher-level actions by learning and naming basic actions. The second model is from Farkas et al., and it uses a biologically very viable reward-based system to learn an action, name an action, and even comment on it, which supposedly brings a fuller understanding of meaning through this commenting. And the last example is from Lali et al. This research team kind of sees action as a teleological coupling of an starting state and an end state, which is supposedly similar to how humans see action. It's not just one isolated thing. It's got a few other connotations like possession and causality, so if, then, and because. And this is what this robot learned, the different shades of an action. And this supposedly then realizes the meaning that we have. So they have a few shortcomings, but these and the like models are being described in the fields, in the field itself as very accurate in modeling natural cognition in assigning of meaning, which I found a bit of, I had a few problems with that, especially how can different approaches all accurately model human understanding. And if they even model it, if there is even any understanding, because you could say, of course, that there is understanding in the limited scope and nature of the robot, but then this problem is not connected to human-like understanding. So my further question was meaning really created? And so these questions are not the first of their kind. They have been similarly posed by one of the biggest critics, most relevant critics of artificial intelligence, Hubert Dreyfus, who said that embodied models do not create meanings, do not directly pick up significance, and improve sensitivity to relevance, responding to what is significant in terms of needs, body size, ways of moving, and so forth. And this is actually based on accounts of some people that we've already heard about today, for example, Merleau-Ponty, and furthermore, Freeman. So my question was, how is that what they're doing, what the field of embodied robotics are doing right now, how is that not just simply mapping a linguistic signal to an action, and how does the meaning arise for the robot itself? So how is it that this meaning comes from something that is innate to the robot and not to the programmer? How come that some meaning that supposedly arises is not just relevant for the programmer, because the programmer actually embedded the robot with all the programs and you know, the implemented code. So in that sense, you could only say that whatever a robot does is just a extended mind, if I use the term that we heard before, of a programmer. So where does the significance arise? What is needed for the meaning to arise for the robot and not actually for the programmer? And I think that this is kind of self-explanatory in a way, because for the robot to get meaning from something, it has to be significant for the robot itself. So it needs to have that meaning to keep itself going. It needs that meaning to survive. And in this way, the robot needs to be autonomous. I identified two problems, like I've told you. The problem of agency. Who is creating the meaning and grounding it? Who is the recipient of the meaning that is supposedly created? The programmer or the robot? Who finds whatever happens significant? And of course, the second problem is uncertainty of the concept of grounding itself. Because if it's devoid of the supposed agent significance, it's simply mapping. And I offered, the potential solution would be autonomy, like I said, but the problem is that autonomy is kind of a huge buzzword nowadays. So in robotics, everything has to be autonomous and everything is autonomous, but there is a problem with this definition that they use. Namely, that autonomy is kind of So if I read you the quote, the robot is engineered so as to be able to interact with its environment without requiring ongoing human intervention. So this is mostly how autonomy is interpreted. But this can be only seen as trivial or behavior autonomy. But I propose, some of the critics of this field proposed constitutive or non-trivial autonomy, which would mean that an agent would have a capability to determine its own rules of the game that is played. This would mean that meaning would arise for the agent in order for it to survive. The meaning would be created in such a way so that it would be a necessary part of the robot for its existence. Now, there is a huge problem with that because this is hard to model, as you can imagine. And so far, there have been no computational or algorithmic models. So there is a proposition of a design how this can be, which kind of takes from enactivism, and it would be that the system must be capable of generating its own systemic identity at some level of description, which means that identity is actually meant as autonomy. So for a living system, its identity is to be alive, and with losing that identity, the system dies. So it's something that changes. And for a robot, you turn it on, and it does something, and you turn it off, and it's still the same system. So that would be the first design principle proposed by Freuze and Zimke. So to summarize, the background of the current background of the embodied cognitive robotics is that thought is expressed not as symbol manipulation, but as an inner simulation drawing on lower level capacities of the sensory motor cognition. Their claims are that the problem of meaning has been solved, or that the nature of meaning has been a huge breakthrough in that. And the problem with that, and the trends have kind of been taken from the pool of evidence that links language and action to meaning comprehension. But the problem is that meanings can only be significant for the programmer and not the robot, because the robots are externally programmed, so there is nothing in the meaning that would be significant for them and not for the programmers. So the meanings are not teleological for the robot. And the solution is constitutive autonomy, which would be autonomy that is not trivial, that does not just separate the physical bodies of the robot and the human creator programmer, but that the robot would kind of act in order to survive and not in order to realize some external programming. And to conclude, I think that we have to start thinking in alternative contemporary paradigms, and for example, enactivism, which has kind of given this autonomy principle, but also, for example, biosemiotics, which can offer some additional insights. And in that way, maybe sense-making should be the new problem and not symbol grounding as it is now. Thank you for your attention. And if you have any questions.